guys, and welcome to Functional Print Friday, and welcome back to my shop. So as I mentioned at the end of last week's video, this week what I want to do is design some sort of protector to go over the ridge vent on my barn to have a safety line running across without damaging the actual ridge vent. And this is a scrap from the ridge vent that's actually on the roof of my barn, and you can see it's pretty thin material. It's very flexible. And the roofing material comes up underneath this and stops. So it's actually completely hollow underneath, like the first, say, maybe inch and a half at least. So if I was to just take a rope, throw it over the barn and pull down on this, it's just gonna fold this down and crease it, which is not what I want. Now, this design is hopefully gonna support the weight on that safety line over the ridge of the roof. But I wanna point out, because I can already hear you guys down in the comments, if it fails, all that's going to happen is the rope ends up down here where I'm trying to keep it away from and creases this part, which isn't great, but it's not the end of the world. We'll pick up maybe 3 inches in extra length of that safety line as it drops down onto this. No one's going to get hurt. I would not trust something 3D printed with my life up on a roof. And yeah, there's plenty of other ways to do this. My friend and I were kind of just talking about it down in the yard, looking at the top of the barn, and we came up with probably 3 or 4 different other ways to do this with some 2x4s, some plywood, some rubber sheeting with some poles to keep it like the shape from it pulling together. Like, there's all different ways to do this, but what I don't have is the shape of the roof, and anything that I build, I'm going to have to basically get the dimensions to work from and design it to make sure it's actually going to fit and carry the load down to these 2 points, which will make more sense once I draw this out and you guys can see what this has to do up on the roof, because I got some drone shots of the roof. So here's a picture of the roof of the barn that I took from my drone, and we're actually looking at the side that doesn't get the solar panels, but the lighting was better over here to get a better idea of depth of material and just the makeup of this. The sun's hitting this side, so it's a little bit blown out. And yeah, my neighbor's yard is genuinely that trashy. Fortunately, I don't see this because our yard is on the other side of the barn, so the barn pretty much obscures the view of this nonsense. But yeah, so this line of screws that you see here is where the purlin runs along the length of the building on top of the trusses. And each one of these rows of screws, there's a purlin underneath that, including up here. These screws, I think, don't actually go all the way down into the purlin, although it might. I mean, I think it just penetrates the roofing panel here. And then I think the roofing panel is also screwed where it's flat against the purlin, just like down here into it. But point being, if we put a load against this section here where these screws are, we have the stiffness of the standing ribs in the roof, and that then gets carried down to that purlin that runs across the top. And it's the same thing on the other side. So what I want to do is I basically just want to span this. I want to carry the load down here, and I want to carry the load on the other side, where there's a matching set of screws that runs along in line with that purlin. And if some of the load is carried down to the top face of this, that's okay, as long as it's spread evenly. I'm trying to avoid putting load on the very top of this. Like, if we just threw a rope over this and then pulled it taut, it's just gonna pull this down. There's probably maybe 2.5 inches underneath this, so it's just gonna pull it down and crease it. That's not gonna work. That's, again, what we're trying to avoid. So I think from this, we can kind of get an idea of how we want to construct this. It's got to go over this, so some type of an arch. I'd like, again, to sit right against it, because if some of the load then gets carried down to this, not a big problem. We probably want to have some relief at the top, so that we're definitely not putting any weight right at the ridge of the roof. So I think I have enough information here. I also have the blueprints from this building to go check what the pitch is. I think it's 712, but I'm not 100% certain. All right, so before we design anything, we need the dimensions of this piece. I guess we don't know exactly what angle it's going to be. That is going to be dependent upon what the actual pitch of the roof is. But I'm assuming that even though this is going to be bent a little bit to follow that roof pitch, that this angle is probably going to remain the same. And certainly we can measure these lengths. So what I did is I actually just stood this up on a sheet of paper, and I just traced that. What that allows me to do is, rather than try and measure these angles, just sort of floating in midair here, I can now just put my protractor right up on the sheet of paper up at my desk, measure these angles, measure these lengths with the digital caliper, and then I can duplicate this and then sort of in CAD bend this to match the pitch of the roof. So I'm gonna go do that. I'm gonna get started on the design and I'll bring you guys back. All right, so I did a little digging and I was able to find the diagrams that were submitted when I got the building permit for the barn. This is what the engineer had drawn up and confirmed the roof pitch is 712. So from this I was able to get the actual angle of the roof, and no, I didn't try and measure it from the drawing. I just looked up what the angle is for a 712 pitch. And I'd also identified the location of the purlins on here. That doesn't matter for right now, but that is going to matter in the future when I locate and plan out where the rails are going, exactly where the rails are going to sit for the solar panels. So from there, I basically duplicated a small section of roof with 712 pitch. And then I took that tracing that we got from the panel, I drew half of it, I mirrored it, and then I used the angle tool to basically fold it down onto the roof. Because we don't know exactly how this material is going to sit up there for sure. Like this could be pushed up a little bit more, but naturally, if I placed it up there and had these sitting flat down on the top of the ribs, and this sitting flat down on the top of the ribs, that's the shape that it ends up in. So I'm pretty sure that it is more or less in that shape up top. Could they have forced it to be a little higher up, a little lower? Yeah, I guess, but without getting up there and 3D scanning it, we're not going to know. I think this is going to get us close enough. So from there, once I had that geometry, I know we want to carry the load down to here and over this, specifically avoiding that point at the top. I came up with this. And I initially had like sort of an arch lower here. The reason I raised up these side sections is to try and keep the rope from just slipping off. This is going to be pretty tall. If I recall, I think this is 300 millimeters in height. Yeah, 300 millimeters. So it'll be printed with one of these faces flat on the bed. And we'll just let it do supports in here. It shouldn't be too difficult to clean up. So this thing is huge. I don't think I want to, as a first step, try and print this whole thing. We need to confirm that this is actually going to fit against that, that piece of material that we have as an offcut first. And I just kind of want to see how this geometry here looks for this sort of guide area here for the rope. I'm also a little bit concerned about it potentially splitting here. Again, worst case scenario, if this splits, the rope only comes down to the actual ridge, so the rope's going to gain maybe 3 inches where we're attached to it from a safety line perspective. So I'm not concerned from a human safety perspective. Obviously the roof will get damaged though if this does split. It probably won't. I'm probably overthinking it, but I'm still kind of thinking through how this could potentially be strengthened here. Because we want to print this, well, we almost kind of have to print it with like one of these faces down on the bed. And that's also what's going to give us the highest strength, because we're carrying the load from here down to here. So if the tool path is running all the way around and stacking, that's going to give us a tremendous amount of strength pushing down from up here. It's not going to want to split down here. I'm still a little bit worried about it potentially splitting here though, because the rope will cross it on a layer line. And that's also kind of why I want to just maybe print out just the center section here. So I think that's what I'm going to do. I think I'm going to essentially do this. If I explode this quick, you guys can see. I think I'm just going to take this and do a temporary one with like the sides pulled way in like this. That'll give me the ability to take this up. Hopefully, I think my ladder is tall enough to get up to the top of the roof, the peak, just from the side of the barn. And set this down and actually see if it fits, and then I can kind of just see to my eye what this geometry looks like. All right, our test print is complete, and I did make one minor adjustment on this before hitting print. And again, this is just the center section of this. This whole thing is going to be much larger than this, but this is just the center section where the rope crosses, and so we have a profile here to test. I added these recesses for screw heads. I wasn't thinking in the initial design about the fact that the total length of this is going to exceed the distance between the screw heads, because you can't see it here. This is just an offcut, but the underside of this face screws down onto the tops of the ribs that come up from the roofing material. So there's a screw positioned every, I don't exactly know what the spacing is, but it's not big enough that this would sit in between the screw heads. It's going to have to sit on the screws. So by having these recesses here, obviously it's not going to be flopping around, but I think it's also going to give us the added benefit of this kind of keying into place so that it can't slide on the ridge. I guess we could also see how this fits on here now. This does not follow the pitch of the roof, but this should be that 7/12 pitch. So we can kind of bend this to fit in there. And it's okay. What I don't like is I'm seeing this edge is not, that should be up here. Instead, it's kind of a little bit past here. I think when I designed this, I forgot to leave some clearance there. So this is why you don't print the whole part first. I think I'm gonna have to slide these feet down a little bit to make sure that we're not binding on those corners. So if I slide it this direction, I can show you what I mean. Yeah, that's what I want it to look like. I want to have a little bit of gap there. But if I look at this side now, you can see that it's interfering. So I'll adjust that. I also, now that I'm seeing this, yeah, I don't know about this part for the rope to go through. I don't know if that's a good idea or not. I got to think about that some more. I think what I'm going to do first is, my friend Tom is coming tomorrow, and we're going to put the ladder up against the side of the barn and go up to the peak of the roof and test fit this. So I think I'm going to extend these out, and I'll print just like a thin profile test piece so that we can get up there on the roof and make sure that it is actually going to fit. Because I'm just kind of guessing exactly how this is conforming to that 7/12 pitch. So let me go do that. I'm going to print that out. I'll bring you guys back. All right, it's the next day. The profile piece finished before Tom got here, but unfortunately my extension ladder does not reach the peak of the roof. It reaches just fine to where the gutter is, like the bottom, the lowest part of the roof, but it doesn't reach up at the peak where I wanted to test this. He's got a taller extension ladder, which we're gonna need to actually put this in place, because my idea is we can use a long pole and just have this basically hanging on the pole and reach out and set it down into position over the roof, and then throw the line over and use that same pole to just make sure that the rope is lined up on this before we actually go up on the roof. But that means I wasn't able to actually test this. We can test it, I guess, with this, just sort of the same way, just to make sure. Yeah, now we have plenty of room on either side. So, all right, I think even if this isn't bent in the exact position that I'm kind of anticipating it's gonna be to follow that pitch, I think we have enough clearance on this. So we can keep going. Let's get to a final design on this. I'm gonna go do some drawing. I'll bring you guys back. All right, guys, I have been doing quite a bit of thinking and head scratching on how to improve this roof protector. Probably more than I should be, since it's never gonna get used again, and there's other ways to do this. But I'm down this road. You guys that have been here on the channel for a while know that I tend to get in the weeds and over-engineer stuff like this, and this is no exception. So first thing I did was I swept these down at an angle a bit so that if the roof does pop out of the sort of guide groove here, call it, that it'll naturally want to drop back down into that. And you can kind of get an idea now seeing the addition of those cutouts for the screws that you saw on the test piece. This will kind of key in over one of those screws, and then the rope will run up the center section. Problem is, we're gonna be pretty close up to the peak of the roof, and I started to kind of imagine the angle that the rope is gonna have coming off the top of this, and there's not too wide of an angle is gonna be supported the way that this is presently drawn. Now, I think we're gonna have to pick this up and move it a couple of times. So, you scooch up to the top of the roof, sit down on your side so that there's slack on the rope. Just pick this guy up, slide it over a foot, 2 foot, left or right, whatever you need. At least as we're working up close to the peak, and then set it back down, and it'll key in place down over a set of those screws on each side. Thing is, I just kept getting stuck on not liking this design at the top. And I also came back to, what if this thing splits down the center? And I thought, what if we made it 2 different pieces? What if we had a part that was printed in a different orientation that keyed in up here? So I lowered these down even further, and I actually designed this in a modular fashion. So the white part is one print, and the orange part is a separate print. And if I hide this, you can see this is pretty simple here. So this will still print standing up. This face will be on the bed, or the other face, doesn't really matter. There'll be supports that fill this in. I'm not really worried whether it's clean or not, because that's not our final surface. And then there'll be another part that just gets glued in place. Well, I'll use some gloop or something like that. That has really, really nice soft transition, so that as the rope crosses the top of this, it can come off at a much steeper angle without putting weird forces on this guy. Because you can imagine the weird forces that are going to occur if we have a rope, say, coming off like over this edge. It's going to be trying to tip this guy over. So here we are in Bamboo Studio, and I don't think it hit me just how large this object was until I actually dropped it down on the virtual bed of the Bamboo Lab H2D. This thing is huge. I think the footprint of this might fit on the QIDI Plus 4, but it would not fit in the Z. I think the Bamboo Lab H2D is the only machine I can print this on. I suppose I could print it on the Neptune 4 Max, but my money would not be on this object finishing before failing on that machine. I think there's just too many complex geometries on here that would cause the part to shrink. That machine's unenclosed, the bed warps all around while it's printing. I would not trust that machine to do this part. But this should be no problem for the H2D in theory. I guess this is kind of trial by fire because I've only done just small prints on that machine to kind of test it out, but this thing is huge. If we flip over to the preview, you can see this is 2 kilograms of filament, and it's going to take 2 days, 6 hours, and 58 minutes if we include the prepare time. It's a good thing it's Tuesday. Otherwise, this would not be done for Friday, and I think it goes without saying, if this fails, it's not going to be done in time for this week's video, but I don't think it will. I think this is going to print successfully. I think for the H2D, this should be a pretty easy print, even with the support here in the center. And you can see this guy is really, really strong the way I've sliced it. We have, I believe I have 6 walls in here, and I have gyroid infill. I know the infill doesn't matter as much as the outer walls, but I do really like gyroid infill for models like this because I think it spreads the load out really evenly versus grid infill that can give you some stress points on the infill. So that's probably also what's driving up the majority of the print time here, is gyroid infill just takes a long time to print, and boy do we have a lot of it. So, all right, I guess I better stop talking about it and actually go hit the print button. I still have to slice up the center section here as well and print that separately. I don't imagine that's going to be very hard to do, and that should print pretty quick. So, all right, I'm going to hit print, and I'll bring you guys back. All right, guys, this thing is absolutely massive. I'm pretty sure this is the heaviest object I've ever printed. I think the giant Benchy that I printed just as a joke might be a little bit larger than this from a volume perspective, but it doesn't weigh this much. That thing's printed pretty light. This is a solid, just shy of 2 kilograms of material. And here's the filament that's left over. I didn't weigh this, but I think we're pretty close. I think we were supposed to have like 80 grams of filament left. That's pretty close. There might be a little more than 80 grams on there. I did knock the extrusion down to 0.975 from the default of 0.98, just to make sure that we didn't end up with any over extrusion since we had 6 walls on this. It looks pretty good. Might be slightly under extruded. I probably could have left it at the 0.98. I think that H2D does a really good job tuning the filament automatically. And the filament I use for this is Sunlu PLA Plus 2.0. Sunlu actually sent me 2 rolls of this blue filament a couple months ago for me to try out, and I was just waiting for the right project. And this ended up being it. So thank you, Sunlu, for sending out the filament for this. Ended up essentially making this print free. The print quality on this looks exceptional. The H2D did a really, really nice job. Now, you could say this print shouldn't pose that much of a challenge, but I have found that really large prints like this that are in weird shapes just tend to generate some unusual stresses that can cause warping in the print, but everything on this is dead straight and dead flat. It didn't lift from the bed anywhere at all, but once it completely cooled, I didn't even need to pop the plate off to break it loose. It was completely loose on the bed. All I had to do was just lift it out of there. Supports look like they came out really clean as well. Again, I did no tuning on this filament whatsoever. This is all just the automatic tuning that machine does. Like a little wisp of filament here, probably from where the supports were. I don't know if the camera's even picked that up. It almost looks like a hair, but that's just like a wisp of PLA. But yeah, I mean, this came out great. I am curious to see how clean these interfaces are. Well, it took longer to move the tripod than it did to remove the supports. I don't know why I thought that was going to be such a fight. That pretty much came off in one piece. In fact, the top interface is still completely attached to the supports. The bottom interface came off in two pieces. And the bottom interface on the part looks really, really clean. Can't even tell there was a support interface there. And the top looks pretty good. I mean, it looks about as I would expect it to look for supports with a Z-gap done in the same material that is on a plane upside down relative to the bed that it was printed from. I think if we had done like TPU as an interface layer for these supports, it probably would look even better, but we're not going to see this. This is not, nothing's going to be touching that. That's going to be completely obscured by our insert piece here. So, all right, let me go get the insert piece for this printed. All right, well, that ended up being a lot harder than I expected. I thought this was going to be super easy to print. But the particular shape of this part ended up being really, really hard to print because it comes down to such a small point at the bottom on each side. I just figured the support would take care of it, no problem. But yeah, I even tried printing this on a raft. I don't remember which one of these that is, but even the one that I printed on a raft, I think it was this one. Even the one that I printed on a raft failed, because it's just such a thin interface layer between the raft and the bottom of the part. This one was also a failure, and you can see this side was okay. It must have kind of set down on the support just enough to follow it, but this side, it never really set down on the support. That was the other challenge I had with this. The slicer, regardless of what I did, only wanted to put an interface layer at the very top. This long sloping section, regardless of what I set the angle to, what I set the Z distance to, I tried tweaking everything. I could not get it to draw interfaces for the supports on these long sloping sections. And I'll make sure the STL is available to download for this if you don't believe me and want to try slicing this for yourself. If you come up with another way of doing it, you know, great, tell me what it is. But again, I could only get it to draw interface for the supports right up here at the peak of this. That was it. I did finally get one to print by making a couple of changes. I actually had to modify the design itself to have a solid face at the end. It's only 0.5 millimeter thick. I did the same thing on the other side, and then I put a 0.5 millimeter thick section down the middle so that the entire structure was supported from the bottom up. And it's still lifted a little bit at the edges, just I think that's the material shrinking just because of the really weird shape that is. So I've left us some extra work to clean up, but that's okay. I think they will break off without too much difficulty, and all I really care about is the smoothness of this surface up here, which looks to have come out really nice. The other thing I did, but I had done that on several of these that failed too, is I just dropped it down below the surface of the bed a little bit so there was more of a contact area on that corner where it comes down. I think there was 3 line widths wide where it contacted. Now, I did that on at least half of the failures that are up here as well, but that wasn't enough. It literally took modifying the design to have solid sides to get a successful print. All right, let me get you guys out of the way. I'll try breaking these off and cleaning this all up. There, you can actually see after I broke the rest of the supports out, that's the interface layers there. You can see how straight they are? That's because that's the only place that the slicer would actually draw the interface layers, no matter what I did. All right, that took probably about 10 minutes to get that all cleaned up. And it doesn't look that great, but it is nice and smooth. If I cared what this looked like, I'd hit this with a heat gun and would actually probably clean up pretty nice. The two tools I used the most were a wood gouge and a wood chisel. If you have woodworking tools like this, if you're doing heavy support removal, these work really great, and the sharper, the better. I used a deburring tool on the edges as well. So I think we're ready to see if this is going to fit in here. And I did clean up that interface edge that was a little rough with the chisel as well, just to make sure we have a good amount of clearance. I tried putting this in upside down just to see if it fits, and it does go. It is a nice snug fit in there, which is what we're looking for. I think we're probably going to have some gaps down here at the bottom where this just curled up a little bit in the print, but I think I'm ready to put this in. Now, once it goes in there, I don't think it's coming back out. So I think friction alone would hold it, but I want to try some of this gloop in there as well. I haven't used this in about 1.5 years, so I don't know if this is still good. This will be an interesting test. This stuff is not cheap, so I'm hoping that it lasted this long. Yeah, it looks like it's still a liquid, and I don't think we lost any, so that's good. Looks like this stuff does last a while. All right, well, given the angle of the camera, you guys probably saw my big mistake there way before I did, but it looks like we lucked out. I see a little crack here and a little crack here, but this actually did not break off, even though I was hitting it with that soft face hammer, and I did manage to get it to seat down in there nicely. In fact, this fits kind of better than I expected it to. There's a little bit of an edge here, really no edge there, no edge there, maybe a little bit of an edge here. So the fit's not perfect, but it's pretty darn good. Now, wherever you drip that, this gloop stuff, it does really eat the material. I mean, that's what it's designed to do. So I dripped a little bit there. I wiped it off. It's nice and smooth. If this was a project that appearance mattered, you'd probably want to just tape over with like masking tape all the surfaces that you don't want to get any of this stuff on. You know, I just noticed it is actually a little bit rough right here at the top of the print, just because in printing in that orientation and being a curved surface where all these layer lines kind of come down to meet here right in the center. The orange piece I printed at 0.12 millimeter layer height. The overall model is printed at 0.2 millimeter layer height. So, I think I might actually hit that with some high grit sandpaper, and maybe I'll hit that as well, and then just hit it with a heat gun quick and see what it looks like. Oh, and you know what? I just realized we didn't actually take the supports out for the relief here for the screws. So let me do that real quick. All right, I started off by sanding everything with 320 grit sandpaper. And if anybody knows where I can get more of this, I would love to hear about it. I showed this about 2 years ago on the channel. This is like a plastic backed sandpaper from 3M. I bought this just at like my local home center, probably Lowe's, maybe 5 years ago. I think I only bought 3 sheets. I'm still on the 3 sheets that I purchased. I'm convinced that 3M realized they invented sandpaper that was too good and took it off the market. This is one of those cases where the marketing is an understatement. It says lasts 15 times longer. No, this stuff lasts 150 times longer. It is, I have a piece, hold on. Yeah, this is the piece I use on metal. This thing has been stretched out, abused. It's had all sorts of different lubricants and solvents on it. It still works just fine. It's got a small hole worn through it here. The backing feels similar to like TPU plastic, maybe. And it's very flexible like that. Like I can stretch it and you can sort of hear a little bit of a tearing sound. I think that's actually the adhesive and the whatever is on here. I don't know what's bonded to it, if that's like a glass or some kind of garnet. It's very fine, but this stuff is exceptional. Let me know down in the description if you have a source for this stuff. The last thing you saw me do on here was I sprayed just a little bit of silicone lubricant. Let me grab it. This stuff here. I'll put a link to this down in the description of the video. This is the first time I tried this. I put just a little bit of silicone spray on the shop towel, like not a lot, maybe about like the size of a quarter on here. And then I gently wiped the whole surface of this print, since I want this to be nice and slippery, it almost made this disappear down here where I had sanded it and it was like a little bit lighter. And the whole thing is just like super smooth and slippery now. Like that worked really well. Hopefully there isn't some interaction that I'm not aware of between silicone and PLA. It doesn't seem to be breaking down at all. And it's made the whole surface like just that little tiny bit. Like I did not saturate this. Like don't go crazy with it. But just that little tiny bit and then wiping across the surface, the whole thing is super slippery and smooth. Well guys, I think this is done. It's going to be a couple of weeks until the rest of the stuff is prepped for the solar install, so stick around if you want to see this guy actually in use up on the roof. But yeah, I'm really happy with how this came out, and I'm happy with how this insert design came out as well. I think we have the best of both worlds with the layer lines running in the strongest direction for the different applications of strength that we want in this part. Guys, as always, thanks for hanging out in the shop with me for this week's design and print. I realize there's probably about 0 people watching this video that are going to want to make their own roof protector for a safety line for the metal roof on their barn. But if by chance you do, I'll put the STLs for this on my site, fpfdesigns.com. And feel free again to take this insert piece, the orange part that you see here, pull it into your slicer and see if you can get the supports to work better than I could. This is one of the most challenging things that I have ever printed, this orange insert, which boggles my mind. I generally do not have a problem printing just about any shape anymore. I feel like I've got a pretty good command of the tools in the slicer to get the supports that I need. I cannot believe I actually had to end up modifying the design to get this to print. But yeah, feel free to pull this into your slicer, see if you can get it to give you interface layers on those long sloping surfaces. And if you come up with another idea, I mean, maybe even print it and see if it works. This is not that much filament. This is maybe like 125 grams of filament, I think, for this part. So it's not a whole lot of material. Maybe you've got an old spool with just a little bit left on it that you want to try and see if your idea works. And if this is by chance your first time here on the channel, this is all we do. It's all functional parts like this. So if you're interested in more of that engineering side of 3D printing, check out some of the other videos on the channel. And if you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.